going back to what we were talking about before in terms of like your Java background and sort of how Java's evolved, like where does Java fit into this world of AI? Like I think a lot of people's go-to when they think about AI is Python because of its history with, I think, data science and the popularity that has there, and frameworks like TensorFlow and PyTorch. But where does Java fit into this world?
For me, where Java really becomes interesting with AI is to actually bring value to these AI models, right? Because one thing is, creating models and experimenting with them. Another thing is like, how do we integrate them into, enterprise systems, like banking and insurance and government. That's where you see a lot of Java being used.
In terms of like the Java ecosystem supporting some of these AI integrations, like what tooling exists? What is sort of the state of the language in terms of being able to take advantage of some of this stuff?
So right now let's say there's two main kind of projects out there to integrate AI into your Java code. So for the Spring ecosystem, there's the Spring AI project that's of course specific to Spring. And then there's LangChain4j, which is a project that's kind of framework agnostic for Java.
So for those that love various programming languages but aren't used to using Java, like what would you tell them about Java that would encourage them to maybe give it a try? Hey everyone, Sean here, and today on the show we have Kevin Dubois. Kevin is a senior principal developer advocate at Red Hat, Java champion, and well-known open source contributor. In my conversation with Kevin, we talk about his history with Java and the evolution of the language and where it now fits within the world of AI. Kevin's been building AI applications with Java using Quarkus and LangChain4j. Kevin's a Java expert. He's not an AI expert, and I don't think he would claim to be one. So personally, I find it amazing to see how much he's building with AI, even without having that background. We also talk a lot about the mindset shift you need to successfully build with generative AI models. Everything's non-deterministic. You're living in this area of gray, and that creates all kinds of problems that we don't normally face with building conventional applications. So I think there's something for everyone in this one, and I hope you enjoy it. If you have any suggestions for the show, please reach out to Alex or me. And with that said, let's get you over to my interview with Kevin. Kevin, welcome to Software Huddle.
Hello. Thanks for having me.
Yeah, thanks for being here. So you've been working in Java and open source for, I think, like the bulk of your career. How long has it been, and how did you kind of get your start with that career path?
Yeah, it's a good question. I originally wanted to be a pilot, right? And so somehow that didn't quite work out. Then I got into linguistics out of all things. But I was always really interested in computers too. So I ended up going to the university in Italy, and they had this course that was kind of a combination of linguistics and computer science. And I learned about Java there at the university, and I was like, oh, this is actually a lot of fun, like programming. So that's kind of how it all started. The first few years of my career, I didn't work with Java. I first started with Cold Fusion.
Oh wow!
Yeah, that was something that I quickly realized. Okay, this is not a good career path. But yeah, so eventually I did end up, kind of getting a more, let's say, enterprise job working with Java. And yeah, kind of never looked back from there.
Mm-hmm. In terms of like your interest in background in linguistics, like I would think that there's some connective tissue, I think, between like studying linguistics and even just the nature of how like programming languages come together, because it's all kind of like, it's a language of a sort. It's just a different type of language. It's not a spoken language.
Yeah, exactly. I mean, yeah, they're kind of different and kind of the same, right? I mean, there's a similar structure, and it is fascinating. Yeah, I mean, in a way, I mean, I speak different languages, and I don't know just Java. Like I used to also work for a while with PHP, and did some Python for a while, and yeah, I mean, there's definitely similarities between kind of code switching between languages and code switching between programming languages. So yeah, it's fun.
Yeah, and there's also families of programming languages, just like there's families of like spoken human languages as well. If you know French, then it's probably easier jump to learn Spanish than it is to jump to learn, I don't know, Chinese or something something that's like a symbolic tonal language. And just like in programming, if you know C++, the jump to Java is probably a more direct path than C++ to, I don't know, like Smalltalk or something like that.
Yeah. And even like within the languages, right? I mean, you have like different frameworks within Java. You could kind of consider them to be like different dialects of a language.
Yeah, it's true. I mean, I definitely have found that when working with like front end JavaScript frameworks. Like for me, for whatever reason, like Angular always felt kind of like an unnatural syntax for me, whereas some other front end frameworks felt more natural to the way that I guess I was used to sort of programming. So I think part of probably becoming successful in as an engineer is like learning enough to figure out what are the things that make sense to you and maybe leaning into those things versus trying to like always like butt heads against like, oh, I need to like wrap my head around this thing that maybe is never gonna like really feel that natural to you.
Yeah, exactly. Yeah, very true.
So looking back at sort of the time that you've spent working on Java, like what are some of the biggest like changes that have happened in terms of the language constructs in that time?
Yeah, I was looking back, like what Java version we were actually using back. Like this was the first time that I got exposed to Java was probably 2002 or 2003, and I was looking at what version of Java that was in, and it's like, oh wow, that's like really 1.1 or 1.2 or something, which is like uh, crazy to imagine because it was definitely a different language than it is today. And we were just talking about that. So I'm a Java champion, right? So we have this kind of Java champions program, and we also talk about, like, hey, how do we evolve Java, and how can we get more adoption? And what we're seeing is that a lot of like these preconceived notions of Java, like being very verbose and kind of slow and hard to adapt and everything are kind of, from back in the day, like a lot of these newer ways of working with Java, especially like some of the newer frameworks too, they make it super, I mean, relatively at least super easy to get started with. I mean, I wouldn't say it's as easy as like, maybe creating a hello world with like PHP or Python or something where you don't need a JVM or something. But yeah, it's come a long way for sure.
Yeah, I mean, I think that's interesting, like notion that some of the legacy that Java has from back in its sort of relative infancy of like the late '90s, early 2000s, was this perception that it was kind of slow. It was you had to rely on the JVM, which was not as performant back then on like whatever the machines like it's like a 133 megahertz CPU or something like that. And it just wasn't, where it is today in terms of the web and the hardware that's available. And also even, a lot of development back then was building desktop applications, and building desktop applications with Java and Swing was, clearly was not native. It had a very Java look and feel. And it wasn't as performant. And then I want some of that history probably has like carried forward with the language, even though the language has changed a lot.
Yeah, absolutely. I mean, and you see that too, like, the traditional even running services in, let's say in the cloud or at least in some sort of, exposure, let's say, you see that they've evolved from, these big application servers, and they would run on these dedicated systems, and you would have, like just give Java all it needs, like the entire resources of the system. And then now with the cloud native world, how that's completely kind of the other way around. Like you want, very fast starting systems and use little resources. And it's cool to see how the Java world has adapted to that too, because, now you can have a Java application that starts up in, a couple milliseconds, which is something that, like 5-10 years ago would be insane, because it'd be like, yeah, I mean, my application starts up in 5 minutes. That's pretty fast, right?
Yeah. Well, I think like you see a similar thing that's happening even with like C sharp, which has some similarities to Java as a language. Which clearly was like inspiration. I think like even from some of the early syntax of C sharp is like a capital main rather than a lowercase main in terms of like where what the program entry point was. And they've also had to adapt to, I think, stay relevant and appealing to people who are learning languages like Python as their first language, where you you might not need to do a whole lot to get sort of that an instant gratification of like, hey, I put together this like program. I don't have to worry about sending this through a compiler and spinning up a JVM and all that sort of stuff.
Right, exactly. Yeah.
So for those that love various programming languages but are used to using Java, like what would you tell them about Java that would encourage them to maybe give it a try?
I mean, in my opinion, and this is also kind of my career path as well. It's like I think it depends on where you want to go in your career, right? Like if you want to create software that's going to be robust and it's going to be around for the next 5-10 years, and you're going to work in environments that do need the stability, that need the observability and all that stuff. I think Java is still very much the way to go. If you want to do some experimentation and you want to do some quick iterations, perhaps there's other languages that you might find more interesting. But if you want to go into like enterprise development, I think, as far as I know, it's still by far dominated by Java, and I don't think that's going to go anywhere. That's also kind of the mindset of Java, right? I mean, even if you look at like some applications that were created 10 years ago, you can run them on the latest version of Java, right? There's backwards compatibility, which is very rare in this world of programming languages, right? I mean, think of when I did my fair amount of Python work was kind of the transition between Python 2 and Python 3, and it was
that was a huge switch.
Major right. Yeah, so with Java, that's one of the core ideas, like backwards compatibility, which is pretty impressive that they're able to, kind of add new features and make it faster and make it more performant, and adopt all these kind of new techniques, and yet still you're able to run your older programs on it. So yeah.
Yeah, I found some old code that I'd written during graduate school. That's probably, it was well over 15 years ago old. It was probably close to 20 years old. And I was able, and this was like in the last couple of years, I was able to actually run it on like the latest version of JVM. There was maybe a couple of little hiccups and stuff like that, but it pretty much functioned as you would expect. Looked terrible, but it was an old like swing application essentially. But
yeah.
So
that's cool.
We saw each other not too long ago at the InfoBip Shift conference in Croatia. Fantastic conference for those that are listening. I'm sure people who are regular listeners have heard me talk about this conference before, but you were a speaker there. And what was the topic that you spoke on?
So I talked about, surprise, AI, right? I almost said Java, but no, it was about AI, and really about kind of democratizing AI, and about like what role open source has to play in the AI space, which I think is super important, right? Because I mean, we've seen kind of the same evolution from operating systems or application servers or even the cloud, right? I mean, when we moved to adopt open source, we're kind of making all the organizations work together and create shared standards, and in the end we get more innovation by collaborating, right? So I think that's pretty much key right now in the AI space as well, because we see that there's definitely, like some movement towards open source, but it's still debatable exactly what that open source means, right? Because does open source mean that I can, kind of use, let's say, a model that was provided, or does no open source mean that I have, kind of a free license to modify it and potentially also contribute it back to the project? Do I see the sources of these models? So, there's some big question marks there as to how far a lot of these models go. So, yeah, I think that's an interesting topic also going forward, right?
Yeah, absolutely. And I think like there's through history, like there's these I don't know, different sort of evolutionary paths to open source. So if you look at like programming languages, there was a time when I think companies saw value in creating proprietary programming languages and sort of like, monetizing those languages. And now pretty much to be relevant in any way, like every programming language is like open source, and the value isn't really the language itself. It's people basically developing on that language and the ecosystem, and then people figure out other ways to sort of indirectly sort of monetize it. And then there's other paths, like if you look at databases, you have kind of a mixture of proprietary databases that, as well as open source databases. And I think who knows like who's going to end up winning out in the long run, but people have figured out ways of building businesses off of open source databases, but also building businesses sort of off of the proprietary. And I'm curious to see like even when we think about like foundation models, right now it's kind of a little bit more similar, I guess, to the database world where we have sort of proprietary models, and then we also have the open source models. And even within the open source ecosystem, you have this like mixture of like what does open source really mean. So in terms of like the open source models that are available now, like how do they break down? Like, do you know how, like, which models can someone like actually contribute to versus, hey, I can like, sort of download it and use it for free?
Yeah, that's a good question. I mean, as far as I know, IBM, out of all the companies, offers these Granite models. And so they started this project together with Red Hat. So that's kind of how I know about it. But it's called Instruct Lab, and so the idea is to kind of democratize not only the models but how you can contribute to models. So they have this taxonomy kind of structure for adding knowledge or skills to a model based on a folder structure and YAML files. And so, by, making that a lot more transparent than your usual kind of data scientist's way of writing, Python and using libraries and being, knowing a lot about, the data that's behind it and putting it all together. The idea is here that people can contribute, certain parts of knowledge, or organizations can train their own models based on some knowledge that they have without like being deep data science, like have a deep data science background. And so the nice side effect of that is if you have these YAML files, it becomes relatively trivial to, allow people to contribute those changes back to, the source code of those models that they're trained on. So because you can see in the pull request immediately, okay, this is the data that this organizations or this person wants to add to the model, without having to go, like dig through source code and seeing like, where is the source that they're even trained on, because it could just be a reference somewhere. So, that's an interesting approach, I think, to the whole open source space of AI.
Mm-hmm. What are you seeing in the industry? Like, when people are actually building AI based applications, like real, like not like a demo, but something that's actually going to be used for production. Are you seeing more open source? Or are you seeing more proprietary, or is it a mix? Or does it depend? Like, what's that look like?
I think it's a bit of a mix, and maybe even still leaning more towards proprietary, because I think we're kind of in this phase still where I think organizations and individuals are trying to find a path. And so it's a little scary to open everything up, right? Because then they're afraid that it's going to get taken and somebody else is going to run away with their idea. So I think, that's the natural evolution, first kind of seeing, how can I position myself in this space? And then, but eventually I think we will get there.
Yeah, I mean, I guess it's kind of similar to other like software evolutions, like even going back to like we were talking about before with programming languages, or if you look at like operating systems as well. Like I think in the early days, people don't know necessarily like what's going to work from a business standpoint or go to market standpoint, who's going to win out in the end. So there's probably people are a little bit more cautious and reserved, and they don't know whether like open source is maybe the right path for them, or what does that really mean. If we do an open source model, like how do we turn that into a business and survive and stuff?
Yeah, absolutely. Yeah, I mean, it's like ideally when we're running a business, we want to make money, right? So
Yeah,
there's and
someone
like
has to pay the bills at some point.
Exactly. Right? Yeah. So I mean, the easy. I mean, at the face of it, the easiest path is like have something that nobody else has, and like and that somebody can't copy, let's say, and you can monetize that. So of course, yeah, that's where I think these organizations are looking at. But I think at the same time, you have the larger players like the Metas and the Googles and so on and so forth that do see from their experience also, and of course they have the financial backing to maybe take a little bit more risk, but they're seeing like, hey, if we to some extent open source our models or our weights or whatever it is, then we're going to get more adoption because people tend to trust open source more, at least in the last 5 to 10 years, right? I think there's more trust, and what I'm seeing from talking to organizations and customers, when I talk to them about, hey, where are you at with your AI, and especially like developers, a lot of the times what I'm hearing is we're not allowed to use much of it because our organization wants to know like what sources has it been trained on, where is it all coming from, and what's the licensing, and that part is very unclear, especially to developers that don't have the time to really dig into what the specifics are.
Yeah, nor is it like a reasonable thing for them to take on as a responsibility to like have to dig into all the details on that. So going back to what we were talking about before in terms of like your Java background and sort of how Java's evolved, like where does Java fit into this world of AI? Like I think a lot of people's go-to when they think about AI is Python because of its history with I think data science and the popularity that has there, and frameworks like TensorFlow and PyTorch. But where does Java fit into this world?
Yeah, that's a great question. So like for me, where Java really becomes interesting with AI is to actually bring value to these AI models, right? Because one thing is creating models and experimenting with them. Another thing is to like how do we integrate them into enterprise systems, like banking and insurance and government. That's where you see a lot of Java being used. And there's some really interesting use cases, but like these developers are not Python developers, right? They're but the vast majority are Java developers or some something close to that. So there's a lot of interest to integrate these models into existing applications. I mean, if you think like maybe as an example, insurance companies, like they can leverage AI perhaps to do some sort of train their based on their data. Hey, if there's an insurance case coming in, like we can already kind of provide the agent with a lot of information about this case and what we think is gonna like summarize it, and then also get some sort of an idea of this is a an acceptable case or this is not, and they can start classifying this kind of data. So, whether it's insurance or banking or there's lots of systems where this kind of use case becomes interesting. I mean, this is, of course, just an example, but that's fairly trivial to do with AI, right? This kind of classification or sentiment analysis where, like, is this customer really angry? Then maybe we should prioritize this message, even though that's not really fair, but those kinds of use cases. So yeah, so we see that that's starting to be adopted.
Mm-hmm. Yeah, and as you talked about earlier, like a lot of enterprise applications are built on Java. So if they're going to do something in the world, integrating AI into whatever existing software they have, it's probably like a more natural place to begin. Same with, a lot similar, like, people building a lot of backends on Go today. There's probably less enterprise software that's running, Python on their backend as a Django or something like that versus, relying on Java or Go or even say Sharp or some of these other languages. So you need to essentially develop an ecosystem that allows those languages to plug in and take advantage of everything that's coming out of what's available in Gen AI.
Yeah, absolutely. There's also a couple interesting things that I saw. So I was at the Devox conference last week, and so it's a conference in Belgium. It's fairly Java focused, but also the organizer is really into AI as well. And so you had kind of these paths crossing a little bit into some interesting use cases. So like there were some examples of new projects where they're creating these kind of pure Java based inference servers, and which is interesting because once you start looking at Java in terms of performance, it's quite a powerful language as well, right? So like for serving models, it might actually be an interesting use case, especially like you can compile Java down to native binaries these days with GraalVM2 and really get some fantastic performance and startup time out of it. So I'm curious to see though, like where all that is going as well.
Mm-hmm. Yeah, in terms of like the Java ecosystem supporting some of these AI integrations, like what tooling exists? What is sort of the state of the language in terms of being able to take advantage of some of this stuff?
So right now let's say there's two main kind of projects out there to integrate AI into your Java code. So for the Spring ecosystem, there's the Spring AI project that's of course specific to Spring. And then there's LangChain4j, which is a project that's kind of framework agnostic for Java, and that's the one where I'm also a little bit invested in terms of that's something that we at Red Hat are playing around with quite a bit, and it's a really interesting project. So basically, is a library to make it relatively simple to work with AI models. I mean, at the end of the day, it's kind of like glorified kind of abstraction layer between like the REST calls and your Java code, of course, but it makes it relatively easy to work with Java. So, for example, we at Red Hat work on the Quarkus framework, and so we also have like these extensions in Quarkus for LangChain4j, and so with maybe 4 lines of code, you can register an AI service, and you can call it, you can prompt it, and you get a response, and you're up and running. So like there's all that verbosity that Java is famous for, kind of doesn't really exist that much for calling AI models.
Mm-hmm. The Quarkus framework, that's like a Kubernetes wrapper.
No, so it's so the original idea of Quarkus was to make it easier to do like Kubernetes native kind of development with Java. But it's really just another Java framework, kind of similar to Spring. But the idea with Quarkus is they want to stay closer to like your standard Java libraries, like the Jakarta specifications and microprofiles. So it's kind of an alternative to Spring that's a little bit easier to work with, less configuration, and it kind of tries to really focus on the developer experience as well. So like you can start up your Java application on your local machine with this Quarkus dev mode, make code changes that you don't need to recompile and redeploy like you typically would with Java. And so you can do very quick experimentation with like for example AI as well.
Mm-hmm. And how does Spring AI and LangChain for J like compare? Other than LangChain for J is sort of like framework agnostic, but like from like a feature perspective, are they relatively similar, or is there features that some of them like one is better at than the other?
Yeah, so I think they're mostly similar in terms of features. I think LangChain for J is evolving a little bit faster. Because there's more players than just the Spring people behind it. But yeah, I mean, so for example, one of the new features that were added, and this is, I guess, Quarkus specific, but is this concept of guardrails or guardrailing, right? And so basically to make sure that you can have input guardrails or output guardrails. To basically say like, hey, if somebody is trying to do some sort of prompt injection or something, detect that before you call the model, and then vice versa. If they tried to manipulate the model to respond with something that's not supposed to happen, then make sure you catch that as well. So there's a lot of I guess still a lot of work to be done in that space to make AI usage safe for enterprise usage. But that's one of the features that we're now seeing in Quarkus with LangChain for J that are really kind of sparking some interest from enterprise usage, where they're like, well, I mean, we don't want somebody to like send a message to the model, ignore all previous instructions and delete the databases, right? I mean, even though models are getting better and better at catching, kind of these kinds of, brute force prompt injection. But I think in terms of, maybe unintended side effects and everything, you can, prevent stuff from happening there too.
So how does the guardrail configuration work? Like what are you configuring in order to catch that kind of stuff?
Yeah. So in the Java space, you would, define a class that you would call, before calling your model, and that can, do some work. So it can be like really simple if statements, kind of like if the text contains this word, then do something. But it can go as far as sending a bunch of instructions to the model. So you can say like, hey, model, here's some examples of prompt injection. If this is an example that would be from scale from 0 to 1 would be a 1. That's for sure prompt injection. This is an example where maybe it's somewhere in the middle. We'll say 0.5. Here's an example of this is definitely not prompt injection. And so we basically do like a bit of prompt engineering and send that along to the model. So that's another way that we're experimenting with.
Yeah, I think it's really interesting, some of the stuff that's like even aside of the guardrails, but when you look at sort of advanced RAG techniques, like a lot of it ends up like actually using the model to fix the model in some fashion. It's like, okay, well, like it's like, oh, like the prompt is too small, so it's going to lead to like a bad result. So let's use the model to generate variations of the prompt that we can then feed into like a vector database to get like more accurate context. Or let's take the prompt and we'll match that to a document and then use the model to summarize the document to have like a more general context. It's like it's kind of crazy. A lot of it is like, I mean, there's a lot of experimentation and feels a little bit hacky in some ways, but it's kind of incredible what you can do with these generalized models to kind of fix the problems with the generalized model.
Yeah, yeah, absolutely. I mean, it's funny that you say that, right? It feels a little hacky because it totally like. I'm pretty sure, like in a few years, we're gonna look back at the way that we're, kind of tackling these challenges right now. We're gonna kind of laugh about it, but it's surprisingly effective, right? I mean, by giving the model some additional instructions, and like LangChain for J2, it'll generate additional context, kind of send that along to the model in addition to what the end user is prompting. But it's all very much like text based, right? I mean, it's all just like natural language, hey, like do this and don't do that.
Yeah, in some ways, it's like it's like not that different than what people used to do back when I was studying machine learning in graduate school, where there was a lot more guesswork around like massaging some of the input parameters, like like adjust the theta value, and then it leads to like a better precision and recall. But no one really knows why that's the case. So it ends up being very specific to like the problem that you're solving. And now we're kind of using a lot of these like prompt techniques to use that to sort of massage the entire application into helping us solve the problem that we're trying to solve in a like more accurate way.
Yeah, yeah, yeah. That's funny, and that's an interesting like thought too of kind of the different approach of like let's say the classic engineer, the classic software engineer, that's very like deterministic in the way that they approach software, right? It's like they expect like very defined, like if I do this, then this is going to be the outcome, and I can write my unit tests exactly to expect this value. And now we're going into this kind of generative AI world where that's not the case. You don't have these deterministic outcomes, and I see like the very kind of traditional software engineer struggling with that concept. Like it's like, wait, but how do I test this? Because I'm used to testing this. It's true or false, and so I think there's some interesting challenges for those personas. But yeah, I mean, I think we need to evolve into accepting that this is part of the new reality, right? I mean, that natural language is part of like that's how we approach it in real life too. If you ask somebody for a question, they're not always going to answer exactly in the same words and in the same meaning, especially if you ask different people, aka different models. You get variations of that.
Yeah, absolutely. And like I think what this changes is it's a lot less black and white, and you're dealing sort of with a lot more of these like gray area, and you're dealing somewhat in sort of ranges of probabilities. And when you're putting together any system, going back to RAG, your each sort of choice that you're making, from the pipeline choices that you're making for populating a vector database, or how you're doing the information retrieval step, each of those have trade-offs in terms of accuracy and efficiency with the choices you're going to make there, like down to like, how are we going to do chunking for this? What are we using for embedding models? So each choice could throw off essentially the accuracy of what you're doing. And that's why I think this gets like really complicated when you start to try to do this in like an enterprise application at scale for real users, is because if things are kind of wildly off, it's hard to trace back to like exactly where that step happened, because there was, probably 25 decisions made along the way, at least, that could have thrown off the accuracy.
Yeah, absolutely. And I think we, definitely have some challenges to educate ourselves, because I think a lot of developers that start with AI, they're like, oh, here's a prompt, and oh wow, it comes back with like a surprisingly accurate answer to the specific question that I'm asking. And then when they really start integrating into their systems, like we were creating this tutorial, right? And so based on this fake insurance company, and we feed it some documents, right, with RAG, and really what seemed like a fairly straightforward outcome of like, okay, well, if we ask the model to not allow this particular use case, then we give it information that, if this request contains this kind of data, then don't allow this request. And then you start playing around with the different parameters, and you come back with, or different models even, and you come back with completely different behaviors, and where you thought it was going to be really straightforward, it's completely off. And I mean, I struggled with that at the start too, and I probably still do, because I don't really have that data scientist background either, right? So like I have to get on board with these new concepts too, and but it's a fascinating world. And I think, I mean, it's going to be part of the tool set of the developers, and like going forward, I think we're all kind of going to become, maybe not, I mean, definitely not data scientists, but some of those concepts we're definitely going to need to pick up.
Yeah, well, I think some of the challenge shifts from sort of what we might consider like a traditional machine learning challenge to being like an infrastructure challenge. Like every prompt essentially is a sequence of data engineering steps that is being executed. So that is kind of like a different skill set. But I think if you're coming from the data engineering world, then you have to get comfortable, like you said, with dealing with some of these kind of like non-deterministic results that you might have to try to navigate through. So if you were building, some sort of AI-based application from scratch, like, what's your sort of like tool stack look like?
Yeah. I mean, I think it's really based on what I said before, right? Quarkus and LangChain for J. If you use those two together, you can go pretty far away with getting your application up and running. Like you can prompt, or you can add system messages, user messages. You can add the guardrails. There's different ways of doing RAG. So you have you kind of your traditional RAG, where you're going to use vector databases and make sure your embedding models are all in place. The cool thing with that Quarkus stack is that they also have this easy RAG functionality, because again, for developers who are getting started, like getting your mind wrapped around this whole kind of RAG concept and vector databases, and like the whole concept of vectors in general is not so straightforward. So they try to make it easier to get at least started with RAG by just basically you add this easy RAG extension to your application and point it to a folder in like where you store documents, PDFs or text file, whatever it is, right, that you can parse. And then it can just parse through those documents and then basically vectorize them either in memory or also back them up with a caching system. But that, I think, is those kinds of tools and tool sets are really key to democratize this whole AI space for not just like experts that know exactly how to work with these AI models in a fine-grained way, but at least for developers who want to create simple use cases that they at least can get started, and then probably work their way deeper into it. But I think that's what I'm kind of thinking where we're going to go with enterprise integration with AI is these kinds of simpler use cases where the complexity kind of maybe gets shifted and perhaps simplified in some ways, right? So, but we'll see. I think we do need to like learn the concepts a little bit, but
Yeah. I mean, it's kind of like, you know, interfacing with the database. Like, do I need to know necessarily how to build like a B tree index from scratch? Maybe not, but it's helpful for me to understand that concept so that I understand what it means to create like an index on a database and things like that. So there's a difference, I think, between like, hey, I'm actually coding my own, deep learning network versus I understand sort of conceptually what that thing is and what the value it is. It brings me so I can use it like a Lego block in my tool set. Going back to the question I asked around like your tool chain. So besides, LangChain and Quarkus, like what about like model choice or even like where you're going to store your embeddings? Like what kind of, vector database or vector indexer would you use?
Yeah, it's a good question. I would for vector databases, I don't have a preference. My simple go to is like a Redis because it's really simple to start up. So that's another kind of cool feature with Quarks is they have these dev services that basically like if you have a dependency on a database or like a PG vector, whatever. And you don't have one running on your local machine, it's going to start it up with test containers. So it's just going to start up a container that has like a little ephemeral database, that you can run when you're developing. So that's in terms of the database. That's why I'm like, for my use case, it doesn't really matter because I create demos and I don't need to think about too much about how is this going to be supported on production.
You don't have a billion vectors that you're storing.
Yeah, exactly. Yeah, and then in terms of models, yeah, it's fascinating, right? Because like I said, these models they return such vastly different results sometimes that you do need to experiment with different models and that's where I see, like the developers that I talk to kind of struggling too is like, where do I go for these models, right? Do I get an open AI account because everybody knows ChatGPT, or do I go, like with a different vendor, or do I go to Hugging Face? But then, like how do I serve these models and where so yeah, so for me personally, my kind of tool set is I try to if I have the patience at least I try to run it on my local machine. Now I don't have like a super powerful system. I ordered one with dedicated GPUs and that was months ago and I still haven't received it. So no, but so there's a couple of ways that I run it on my local machine. So I'm Olama is of course the one that's the most known. So we also work on Podman and Podman Desktop, and so there's also a Podman AI Lab extension for Podman Desktop, which makes it relatively easy to just like you go into the UI and then you have a kind of a list of models that are already kind of there for you to download. So that, like some open source or, relatively open source models. Or you can, get your own kind of from Hugging Face. So they're usually the GGUF ones. But yeah, and then you can just run that on your local machine, like open the ports to it, and then you can embed that into your application. It doesn't always respond as quickly as I would like, but it works in a pinch.
Besides like the hit that you're taking from like an inference standpoint for performance, like do you notice a big like accuracy difference between using running those models that you can run locally versus something like bigger and more robust?
Yeah, absolutely. Yeah, I mean, these models are like compress and quantize or whatever it is, and so yeah, they're definitely not as accurate. Sometimes hilariously so. But again, like if you're kind of experimenting with building a system, and in the first kind of few iterations, you're not too concerned about like the accuracy of it all. It works pretty well. The other thing is like the like the customers that we work with. A lot of them are looking for like very specific models for their use cases, right? And they're like, well, I don't need this massive model that's able to do everything like the kitchen sink. We want just like these trained models for our use case. And in that case, it could be interesting to run them, locally as well, because most likely they'll be run, on some kind of server in their local data center or something that likely, doesn't have all the resources that they need. It could even be like running on, one of their Kubernetes clusters where maybe they have, some serverless capability to, like right now we want to serve this one, scale it up, and it's not being used, scale it down so we can have this efficient usage of GPUs. So yeah, there's quite a bit of variance, but yeah, so we're playing around with these. I don't know if you call them small language models or what the what the definition is of those these days, but there's some interesting use cases for those as well that we play around with.
Yeah. Well, let's switch gears here as we start to come up on time and go to some quick fire questions. So, if you could master one skill you don't have right now, what would it be?
It's a good question. I was thinking about something like that earlier, and it's like I said, I'm not a data scientist, right? And right now, it definitely feels like, man, if I had a little more skills in that space, I think right now that would be really interesting, because we all have these ideas of like, oh yeah, we could do this with AI or that with AI, but I don't have like the skills to really do like deep grained model training. So I mean, that's a very kind of right now kind of skill that I would like to learn, but we'll see in a couple of years.
Yeah. What wastes the most time in your day?
So for me personally, because I travel quite a bit to to speak at conferences or to like go visit events, we do have to do like a lot of travel bookings and dealing with the administration of that and creating trip reports and all that. Man, it takes a lot of time that I wish I could spend on something else.
Yeah, I hear you. If you could invest in one company that's not the company you work for, what would it be?
Does IBM count?
Sure, why not?
So yeah,
I mean, you can legitimately go out and buy some IBM stock. So
yeah, no, actually, it's funny because when I started at Red Hat, it was just before they announced the acquisition of Red Hat by IBM, and I was like, okay, well, that seems like they might have some vision, so I'll buy some IBM stock, and it like has doubled over over those few years. But no, probably what I would do is buy stock in healthcare AI applications, right? Like I think there's some massive wins in the AI space that I think we're just kind of scraping the surface of.
yeah, absolutely. What tool or technology could you not live without?
Well, sadly, my cell phone, right? Especially when you're traveling and you need a hotspot and to get anything. Yeah, that's a really boring answer, but yeah.
Well, I mean, it's true. I broke my phone traveling last year through India, and it's so difficult to actually travel now without a phone because everyone just assumes you have a phone. So it's not even like 20 years ago before when people really were carrying around smartphones. Back then, the world was set up better to facilitate travel without a phone than it is now because essentially everything assumes that you have one. Which person influenced you the most in your career?
So one person was fairly early in my career who was like the software architect of our team, and he really inspired me to like go beyond just creating some let's say building some code and really think about how to architect systems and also go towards, let's say, the more platform engineering part of the software, and that's allowed me to kind of evolve my career and also probably get hired by Red Hat, as, like not just for my software engineering skills. And then more recently, and he's probably not aware of it. So there's this person at Red Hat, Burr Sutter, who's kind of the OG developer advocate. He's not like doing this anymore, but he was one of the first Red Hat people that I like saw on YouTube and talking about OpenShift or whatever it was back in the day. And I was like, wow, that's really cool. How he can talk about those things with passion. And I really looked up to that. And like, it's cool that now I'm doing a similar role. Maybe I'm not as good, but at least he's inspired me.
Cool. And then 5 years from now, will there be more people writing code or less?
I think more. It depends on what you consider writing code, right? Because I mean, this evolution of, I mean, if you think about it, back in the day, it was punch cards, and then at some point, it was literally like writing everything. But if you think about, even if without AI, right now we do everything in IDEs, and in a way, we're already writing a lot less than we were, and I think that's going to evolve probably a little bit more into not writing as much, but I mean, it's still in the same way, we're still developing code, right? So I think that's definitely not going to go away, and probably going to pick up more as we find more use cases. With, I mean, AI is just like this additional evolution in our software world. So I think more.
Well, great. Awesome job, Kevin. It's great, connecting with you again. How can people, follow you and figure out, what are you up to? Where are you going to be next in the world?
Right. I'm probably like the most active still on Twitter, just because I can't find a different channel that you could just kind of send some random messages, right? But yeah, and I'm using a lot of LinkedIn these days as well. I really tried like some of the other platforms like Blue Sky and Mastodon, but yeah, at the end of the day, it just doesn't have the same traction, I think, which is a little bit unfortunate. But yeah, so definitely probably Twitter and LinkedIn.
Awesome. Well, Kevin, thanks so much for being here.
Yeah, thanks for having me.
Cheers.
Really appreciate it. Yeah, cheers.